Today's lesson is going to be over inequalities. We're going to talk about the representations of inequalities and how to solve them with one variable and two variables. To start off with, we're going to talk about the four symbols that we're going to be using and what they mean. So the first symbol, my symbols are right here. We have these four symbols. So the first one is greater than. So my keyword is greater than. Okay, so if I say x is greater than, say, number 4, and I want to graph it on my number line, let's say 4 is right here, and I'm going to put an open circle since it's greater than but not equal to. All the numbers that are greater than 4 are to the right of 4 on the number line, so I'm going to shade to the right. So as an inequality, I write x is greater than, and instead of this word greater than, I'm going to use my symbol right here. So greater than 4. That kind of looks like an equal to, so let me just greater than 4. Okay, so if I were to ask you what solution would be true for this statement right here, I can pick any number that's in this shaded area. So a possible solution could be the number 5, 10, 100. Any number that is bigger than 4 would be a possible solution, okay? But it cannot be 4 because our inequality does not say equal to 4. Okay, and we're going to find the possible solutions for the other 4 so you guys can see what that looks like. Our next symbol is the less than symbol. So again, I have x is less than 4 on a number line. Let's say 4 is right there. Again, it gets an open circle because it's not equal to. And the numbers that are less than 4 are to the left of 4 on the number line. So we're going to shade all this to the left and so on to infinity. Okay, so as an inequality, I write x, and instead of less than, I'm going to use my less than symbol, and then 4. And then I'm just going to abbreviate PS for possible solution. A possible solution can be -5, -10, and any number that falls to the left of 10, like 20, -20, and so on. You just pick your favorite number that's to the left of -4. All right, and the last two are similar. We just have something different. These two have an equal, this little line on the bottom, which means equal to. Okay, so the first one is greater than or equal to. Okay, so my example is x is greater than or equal to 4. Again, we'll say 4 is right here, and we put a circle, but this time my circle is shaded because it's equal to 4. All the numbers that are greater than 4, just like the first example, are to the right of 4, so I'm going to shade all this to the right. And then my inequality would be x, and instead of the word greater than or equal to, or the words, I'm going to put my symbol greater than or equal to 4. A possible solution here is the number 4, number 100, and any number that's greater than or equal to 4. And on this one, it can be equal to 4 because our line underneath our symbol means equal to, okay? And then the last one is less than or equal to. Okay, so again, I take my 4 to be right here. I put a closed circle because it's equal to, but this time my numbers are less than 4. So I'm going to shade to the left of 4 like the second example. Okay, so now my inequality is x, and instead of the word less than or equal to, I replace it with my symbol, and then number 4. A possible solution here can be -50 and 4 and whatever number you choose. Okay, so now we're going to take the vocab and the terminology we did above, and we're going to do it with solving one variable inequalities. My essential question here is, how can I use my knowledge of solving equations, which we did in Unit 1, the beginning of the year, to now solve linear or solve inequalities? Okay, so it's going to be similar steps. We're just going to have a couple things that change with solving inequalities. Okay, we have a golden rule that we need to not forget about. And it says, whenever you multiply or divide by a negative number, and it's only when you multiply or divide, and that number is moving across the equal sign, we're going to flip our inequality symbol. Okay, so we cannot forget this golden rule. But all our steps will stay the same besides that when we, in regards to solving, in which we're going to add or subtract our number, our constant, and then we're going to multiply or divide by the number that's attached to our variable. Okay, so just like before, I'm going to split my inequality in half. So before we would split it from the equal sign. So we're just going to find our inequality and we're going to draw a line to split our inequality. Now my variable is y. I need to get y by itself so that it looks something like this, so that I can be able to tell the solutions for the inequality. So what that means is anything that's on the same side as y has to move to the other side. And in this example, I have a -2. To move that -2, I'm going to add 2 to both sides. So I bring down my y, -2 plus 2 is 0, so they're gone. Bring down my symbol, and the 6 plus 2 is 8. And I'm done since y is alone. So my inequality is y is less than or equal to 8. Or similarly, if I flip everything, it's the same meaning. So from right to left, 8, flip my symbol, is greater than or equal to y. So what this means is that these two inequalities are the same meaning. That means that the solutions would be the same. Okay, so a possible solution for the inequalities right here is any number that falls less than or equal to 8. So a possible solution can be the number 8 or the number 7 or any number that you think is that you like that is less than or equal to 8. Okay, my next example, here's my inequality symbol. I'm going to cut it in half. This time my variable is the letter A. Any number that's on the same side as A has to move to the right so that my A is alone. So first we're going to add or subtract our constant. Our constant in this example is 12, and it's positive, so I will subtract both sides by 12. 12 minus 12 is 0, so the 12s are gone. Bring down my -3a and my inequality symbol. 18 minus 12 is 6. Okay, now we're going to multiply or divide by the number that's attached to our letter or our variable, which is a. So I'm dividing both sides by -3. So my -3's cancel out to 1, and I bring down my a. But hold on. We're dividing by negative, and when we divide by a negative number that's going across the symbol, we have to flip our symbol. So now instead of greater than, I have less than. 6 divided by -3 is -2. And now we have our inequality. A is less than -2, or if we flip everything around, -2 is greater than A. So a possible solution that would work, it can't be -2 because of our equals. It's not equal, but we can pick any number that is less than -2. So for example, -10 works, or any number that you like that's less than -2. Okay, we have 2 more on this topic. We'll pick it up a little. All right, I have a t right here and a t right here. So our end goal is to get t by itself on whichever side we choose. So our first step here is we need to make sure our variable is on the same side. So I'm going to subtract 9t from both sides. So 9t minus 9t is 0, so my t's are gone. I bring down my 5 and my inequality. And 10t minus 9t is 1t. Bring down my -3. Okay, so now I only have 1t, and I need to make sure that t is by itself. So all the other numbers have to move. So first I'm going to add 3 to both sides. So 5 plus 3 is 8. Bring down my symbol, and 1t is the same thing as just a t. Okay, so now my inequality is solved. So my inequality is 8 is less than or equal to t, or if I flip everything around, t is greater than or equal to 8 is another way to write that. So a possible solution, it could be the number 8, or any number that's bigger than 8. So it can be 20 or anything that you want. All right, last one. Okay, so now we're solving for x. I have an x here and an x here. So before we can even start moving our x's, we have to get rid of our parentheses. Because remember PEMDAS, we have to do parentheses first. So I have parentheses on the left and a parenthesis on the right. I have to get rid of both of them. And the parentheses mean I get to distribute. So the 3 is distributing into this set. So 3 times 2 is 6. 3 times negative x is negative 3x. Bring down my symbol. The 10 is not affected by the distributive property, but I am distributing a negative 3 into the parentheses. So I get negative 3 times x is negative 3x. Negative 3 times negative 6 is a positive 18. Before we do anything else, we're going to combine like terms. So I'm going to ignore this right side and look at the left. I just have a 6 and a negative 3x. I cannot combine like terms, so I just bring down what I have. Now I look on the right side. I can combine 10 and 18 before moving any further. 10 plus 18 is 28. Bring down my negative 3x. Okay, so now I have to get my x's to be together, just like I did on example 3. So I'm just going to pick one of the x's. I'm going to take the x that's on the left. Since it's negative, I'll add the 3x to both sides. So I bring down my 6, negative 3x plus x is 0, so they're gone. Bring down my symbol, and then bring down the 28. Negative 3x plus x is 0, so those are gone. So my inequality says 6 is less than 28. And this one's kind of tricky, so we have to think about it. Is 6 less than 28? And that's true. So this is a true statement. So our inequality is 6 is less than 28, or 28 is greater than 6. All right. So now for our last part is we're going to be doing the same thing, but now we're going to do linear inequalities, which involves mx plus b. So our essential question is, how can I use my knowledge from y equals mx plus b to solve linear inequalities? So this y equals mx plus b is what we just did on our last test, but now we're going to be doing the similar, but they're going to be called linear inequalities instead of linear equations. So what prior knowledge do I have? In order to know the y-intercept and the slope of an equation or an inequality, you need the equation to be in the form of y equals mx plus b. So in other words, we're going to have to solve for y to be able to identify my slope and my y-intercept. Okay, and as you guys remember from the last unit, we're going to first add or subtract the constant and then multiply or divide by the number attached to the variable in order to get y by itself. So our first two examples, or our first example, our y is already by itself. And instead of an equal sign, we have an inequality symbol that's greater than. And we have our negative 1x plus b. So on this example, I don't have to solve. I can just label my m and my b. I have -1 is my slope, and -5 is my b, or my y-intercept. For the next one, I have to get it into terms, into y equals, or y equals mx plus b. So I'm solving for the letter y. So the first thing I'm going to do is subtract 3x to both sides. 3x minus 3x is 0. So I have 2y is greater than, and remember I can't subtract an x from a constant, so I just write -3x minus 8. Then my last step is to divide everything by 2, like so. And then remember, if we were to divide by negative here, we still have to flip the symbol. But on this one, we're dividing by a +2, so we don't have to flip our inequality. My 2's cancel out, so I have y is greater than -3 over 2x minus 4, because 8 divided by 2 is 4. So now my slope, or my m, is 3 over 2, and my y-intercept, -3 over 2, and my y-intercept is -4. Okay, so let's try a few more. I need to move the variable with the x first, and that's 5x. Since it's positive, I'll subtract it. So my 5x's cancel out, so I have -3y is greater than or equal to -5x plus 0. And then my last step, and the 0 doesn't have to really be there, but it's going to tell us our b, so I'm just going to leave it there for now. And then my last step now is divide by the number next to y, which is -3, to both sides. And this time we divided by negatives, so we have to make sure we flip our symbol. The -3's cancel out, so I have y, and I'll flip my symbol. 2 negatives makes my 5/3 positive. And then anything divided by 0 is just 0, so I just put plus 0. So now my slope is 5 over 3, and my b is 0. So I could have just put -5x and disregarded the 0, but I left it there because it told me that my y-intercept was 0. Okay, next one. Again, I'm going to subtract 5x from both sides to get the y alone. So the 5x's cancel on the left, so I have 3y is greater than or equal to -5x minus 12. And again, I can't subtract an x from a constant, so I just put them next to each other. And I'm going to divide everything by 3. This time's a +3, so I don't have to flip my symbol, so I get y is greater than or equal to, I have a negative and a +3, so it's -5/3 x minus 12 divided by 3 is 4. So my slope is -5/3, and my y-intercept is -4. All right, last two. Split my inequality in half. I'm going to go ahead and put a 1 in front of this -y so that I know that it's there. Going to subtract both sides by 4x. My 4x's cancel. I still have a -1y is less than or equal to -4x minus 2. Okay, and right here, that -1 matters. I have to divide everything by -1. So my negatives cancel, and I just have y. But because I divided by -1, I have to flip my symbol to greater than or equal to. -4 divided by -1 is just a 4x. And -2 divided by a -1 is a +2. So my slope is 4, and my b is 2. All right, and then on this last one, I have y is less than or equal to 2. So my y is already alone, but I have something missing. So I can rewrite this as y is less than or equal to, and since there's not a term with the x, I really don't have an mx present, but I have the +2. So all I did was rewrite my inequality in slopes of mx plus b. So now, because the m and the x were missing, I rewrote that as a 0, and my y-intercept is 2. So I have a slope of 0 and a b, or a y-intercept of 2. All right, and that is it.